Hi, Kafka Streams. Let's talk about it. And in particular, why should we care about it? So we already know about Kafka, right? But there is more to Kafka than just Kafka. There are things like Kafka Connect and Kafka Streams. We are here to talk about Kafka Streams. Surprise, right? So what is Kafka Streams? Kafka Streams is a client library. You can use it from either Java or Scala. And we use it to build stream processors. In particular, we build streaming processors that have Kafka input and output as sources and sinks, if you will. It's a little bit different than the traditional Kafka consumer and Kafka producer. It's built upon it, but it's different in the sense of the APIs that we're using. We still have advantages underneath the covers of being able to scale out and consumer groups and such not. That's all happening under the hood though. As I mentioned, streaming processors are where Kafka Streams fits in, and that is a part of a overall movement towards more streaming architectures. For those of you coming from Spark Streaming, you'll see a lot of similarities in Kafka Streams. So that might be nice if you're coming from there, but not a requirement. Definitely not. Let's take a look at some of the visuals around Kafka Streams. For example, we might look at a very simple diagram like this where we have multiple Kafka topics that are used as inputs for Kafka Stream tasks. The results are written out to a new Kafka topic. Shown another way, it might look like this. Hey, we might still have our Kafka Connect sources writing to Kafka. And we might still have Kafka Connect sinks that are perhaps even pulling from the results of our Kafka Streams applications. Here again, you can see input-output to Kafka from Kafka Streams. Another way to look at it could be like this. Your app is a Kafka Streams app from Kafka. See how the arrows go both ways? The results of your Kafka Streams app might even be used later on downstream. Features and benefits that I like about Kafka Streams is it's lightweight. Lightweight, I can run it on my laptop. I can test it on my laptop. And as you'll see in later presentations, the testing is pretty slick when we start to look at real code. It's based on the JVM, as I mentioned before, about with Scala and Java. The DSL, the Kafka Streams DSL, is very readable, as you'll see in source code examples that follow. We can do both stateful and stateless transformations. Don't worry if that doesn't make any sense right now. It will be when we go over transformation examples. And I'll mention it again, for those of you that are coming from Spark, the API is going to look very similar. In fact, even beyond that, some of you that are coming from even Scala with functional combinators, things like map, flat map, these sort of calls that you're used to in Scala, Kafka Streams is going to seem like a very low barrier to entry for you with having this knowledge already. So how do you use Kafka Streams? There's really two ways. You can use the Kafka Streams DSL, again, Java or Scala. It's higher level. It's the recommended approach to start with Kafka Streams. And then you can also use the processor API. In the testing code that we've had, we used both to show you what it looks like from both of these perspectives. So why do we care? Ultimately, why we care is something going to come down to maybe something personal. So for me, it's personal in the sense that I had played with Spark Streaming a lot for a couple years, in fact, so it was beyond play. And I had used Kafka. But it wasn't until this book came along from Martin Kleppmann that I really changed my thinking around streaming and stream processors. I call this book out, Making Sense of Stream Processing, because if you Google it, you'll find it for free most likely. For example, in the screenshot that I have here, it's being distributed compliments of Confluent. There are other organizations that are distributing this for free as well. So it's short. It's only like 90 pages, and I highly recommend it based on my experiences. If I could be well, so bold as to try to summarize what I learned from this book, I would do so visually, starting with this diagram, where each one of these boxes represent different components in our overall architecture. So for example, maybe we have a web app or a microservice, a REST API that's writing to and from a database. And that's how our app started, and it was pretty simple. But then along the way, we started to introduce components that were more specialized, things like search, things like caching, maybe a traditional queue where ordering didn't matter. We had asynchronous workers, monitoring, and if we're monitoring, we have to notify. You get the idea, hopefully, that we have a lot of specialized components in our architecture. But what I want to call out are these lines, the integration between these things. And what I'm hoping this diagram shows, or what I took away from it from Martin's book, was it's tightly coupled. And when things are tightly coupled in software, it can create a brittleness that can be addressed in a new way. So what if we were able to just blow this up? How would we change it? How would we address the tight coupling, the brittleness that's associated with this tight coupling? We would introduce something called a distributed log. And that log then can be used as a form of loose integration. Loose integration that we might have components that write to this log, and will write messages in a variety of different formats, but it writes so in an immutable way, in an ordered way, so we can then consume from it in a reliable way. Maybe we're consuming it from a search, or we're consuming it from our analytics side, and so on, right? This introduces then, as I previously mentioned, more of a loose coupling. This allows us to be resilient to change. This allows us for things like, if my search system goes down for a couple of days, I can put it back online, replay the log, the distributed log, in the form of messages that are time sensitive or time ordered, and I can get my search index back up to speed, all without affecting anything else in my stack. Pretty powerful. Different than the tightly coupled diagram. So are there any cons? Are there any cons with choosing Kafka Streams as your stream processor? Well, if you're only using Kafka, it should be fine for input and output. But if you're also using other distributed logs like Kinesis or Pulsar, you know you won't be able to use it as of today or at the time of this recording. It's only for Kafka. Now, it's a classic then con in choosing a technology stack that lock-in comes to play. And if you ask me, that can be both good and bad. Sometimes you can be worried so much about lock-in that you have this ultimate flexibility that you don't actually do something really well. So it's tough for me to list it as a con, but it's sort of a classic argument for choosing a particular technology is avoiding lock-in. So that's a concern here as well. But overall, if your input and output is Kafka and you need or want to experiment or have a better understanding of Kafka Streams, it's an absolutely great choice for developing stream processors. So where do we go from here? Well, we're going to get in much more in-depth on where Kafka Streams can help us. And the way I would suggest doing that for some of you is to get your hands dirty, get hands-on. There's a couple of links here that I'm showing, both the Kafka Streams repo as part of my GitHub account, and also superglue.com, Kafka tutorial. I've got a bunch of Kafka Streams related tutorials, all of them hands-on from a variety of different perspectives as well. So I would recommend for those of you inclined to actually start reading and writing and running code to check out both of these resources and start to get your hands dirty. So hopefully you found this valuable on Kafka Streams, Why Should We Care? And please check out the references that I mentioned.